So, hello everybody. Today we are going to talk about programming principles that are called solid principles in object-oriented programming. Sorry, yeah, we don't care about that. Okay, so why did I want to make this talk? Because 3 weeks ago, Mathieu presented the basics of object-oriented programming. I believe that, in fact, generally speaking, these basics are not so complicated to understand. What is a class? What is a method? What is an attribute? What is inheritance? But in fact, the real difficulty is to make a good use of these tools when making a real programming project. And typically, when you start, nobody will tell you what should be classes, what should be methods, what should be attributes, what should be a subclass of what, and so on. And that's what you're going to need to figure out to design your code correctly. Why is it important to write good quality code? First, because it will be easy to understand your code. And from this point of view, an important thing is that your code, in fact, will be read more often than it will be edited. Because yourself, you will spend a lot of time, in fact, reading code that you've already written to think about new features, to fix bugs, and so on. So it's very, very important, and in today's philosophy of coding, it's important not to do a code that the machine will understand, but also to do code that a human being will understand. And also, it will also help you improve the communication between developers and also between developers and the users, which for us researchers are often the same person, because very often the developer will be you, the user will be you, but yourself of today and yourself of in 6 months is not the same person, and you need to communicate with yourself. It will be also easier to maintain the code. And specifically, it will reduce what is called the technical debt, which is a way to say disorganized code, and often you will have a massive need of rework because just want to add a tiny feature to your code, and you say, oh shit, I need to design my whole project again. Easy to extend the code. It's a bit similar. And try to reduce the time needed to implement changes and new feature. And most of the time, when you want to extend your code, you want to have an architecture that is so you change the minimum amount of code, and ideally not at all, but you just will add a new code to add a new feature. And finally, and it's very often underestimated, it will be easier to test your code, so to do automatic testing of your code, and then it will improve the robustness and the confidence that you have yourself in your code, which is, of course, very important for everybody. But for us researchers, for example, if you want to publish your code in the same time as you submit your article, you want to be quite sure that the code does what you say in the article. So the solid principles were gathered by Robert C. Martin in 2000. In fact, all the principles do not come from Robert Martin himself, but he gathered them in a paper. And the acronym itself, SOLID, was introduced later by Michael Feathers. So these 5 principles are the single responsibility principle, the OpenClose principle, the Liskov substitution principle, the interface segregation principle, and the dependency inversion principle. I don't know what it tells you, but to me, it tells almost nothing. Even if the SOLID acronym is meant to be a mnemonic device, personally, the acronym SOLID does not help me very much to remember what it is. But what is interesting, of course, is to look at examples and try to understand better what can be the consequences of our actions, and specifically our bad actions.
Can you move the camera on the screen? The window.
The overlay.
Ah, sorry. Yeah.
Sorry.
Not the camera. Okay. I'm sorry in advance because I will need to take very simple examples, and unfortunately for these programming principles, simple examples are often not that convincing because when you have very small code and very simple code, of course, even if you design it a bit badly, you will always manage to get what you want and to deal with the consequences of a bad architecture. So just keep in mind that, of course, for real life code, the kind of consequences that I will show you that will be tiny on simple example, of course, can be huge for real life example. As much as possible, I will try to illustrate the consequences of bad actions, because just saying the principles just does not make sense. You want to understand what can go wrong in the future if you don't respect this principle. So I don't want to focus too much on theory, but more on practice. Blah blah blah. Yes, and maybe the last point. So for us researchers, very often we do code that has relatively short life expectancy. We just want to do a proof of concept, for example, for an algorithm, for a paper, and so on. So of course we have lower standards of maintainability than, for example, in the industry, in people doing really development code and so on. So and also of course we don't always know where we are going when we start a code project. So even if you do good architecture choices, maybe there will be a moment when you will say, okay, now my project has changed a lot since the beginning, and in fact I will need to rewrite all the code base. That's life. But if you use good architecture principle, I hope that you will make these time-consuming moments less frequent, and ideally avoid them, but I cannot guarantee that. Okay, so for this presentation, I took most of my examples online. I designed one or two of them, but most of them I took them from somewhere. So here are the references, and in parentheses, there are examples that I like the most. So usually in most of these pages, there are examples for the 5 principles. But for example, in this one, I find the most relevant ones are the one for principle S, O, and I, and so on and so on. So the rest of the references. And here we go in the heart of the subject. So the first principle, which is the S in solid, is the single responsibility principle. So Eli talked a bit about it in some sense when he talked about clean code, I think, which say that every class or function should have only one responsibility. And another way of saying that is, I think, a bit more interesting, is to say that a class should have only one reason or one type of reason to change. Why? Because it will be easier to reuse any part of the code, because if you have a function that does many things, but maybe sometimes you will need to reuse only one part of that function, so that should be a separate function by itself. It will be easier to localize error, and once again, I will insist on the third point. It will be easier to create testing for this small portion of code. So, first example, imagine that you have animals with a name and a method that will be designed to dump the animal into, let's say, a format like a JSON. So here I have an attribute name. I have a method JSON dump, which simply use the built-in JSON dumps of Python, and that builds that dumps in JSON format the dictionary containing only the name and of the animal. So now imagine that somebody else, another developer says, okay, I know the class animal. Now I'm going to do a small function that will save to files all the animals of a list. So for each animal in my list, I open a different file and I will write into the file the JSON dump. Of course, here it's a pseudocode just to make it shorter. So let's go. I apply my function to an animal called Dumbo and another animal called Simba. And of course, it does what it's supposed to do. It opens the first file, it tries the dictionary in JSON format, and so on. So do you have ideas about what could go wrong with this design?
If you want to add more formats, then you have to add.
Yes, thank you, Maxime. Okay, so now we have not rehearsed with Maxime. So imagine that you want to add an HTML dump. Okay, so we just had another method called HTML dumps, which does something like, okay, add HTML anchors and blah blah blah. Let's go. But now, how should we adapt the function save to files? We will have a problem. So a possible ugly solution would be to say, okay, now if I want to have the choice of the method that I'm going to use, I will enter the name of that method as a string in the function save to files. And then I will get the corresponding method with the getAt in Python, which helps me to get something that belongs to an object, and that can be a method. And then I will use this dump method in particular. So let's try it. It works. So that was the version with JSON, which is the default setting. And here the version with HTML, and it works. Okay, so where's the problem? In fact, this solution has several drawbacks. First, we lose autocompletion, so it's prone to typos. It also makes the task more difficult for refactoring tools. Each time we will add a dump method, we will need to edit the code of the class animal and possibly if it's a subclass and so on. And maybe the last point is the most difficult one. If a dump method has some additional arguments, like options of how you want to lay out the dump, how you are going to incorporate them in save to files. You could do something with quarks, but it's even more, yeah, we just get dirtier and dirtier. So in fact, here, the simplest solution is to use what is called the facade pattern, which consists in using a different class for the interaction between the animal and the rest of the world. So here, the animal will be just responsible of managing his core characteristics, like its name, and just nothing else. So here's the application of the single responsibility principle is that animal has only one reason to change, which is if you decide one day that an animal has other core characteristics than the name, you will change animal. But if you want to do anything else, for example, adding an HTML dump or doing something with an animal, then you will not change the class animal. It will be the responsibility of another class or another function. So here I just put a little helper function essentially to deal with the option with div, which will add the div anchor at the beginning and at the end of the string. And then I will have a separate class that is dedicated to dumping animals, which is called animal dumper, with a method dump that takes an animal into in arguments. So this one is an abstract class, and then I will have as subclasses animal dumper JSON, animal dumper HTML, and so on. And when I initialize my animal dumper HTML, I can give an optional argument, and this way the dump method of the object always has the same syntax, which is what is important for me. And it's important. Sorry. It's important because then I will be able to use this very simply in my save to files method. I will say, okay, my arguments are a list of animals and an animal dumper whose role is to dump the animal. And for each animal, in fact, I will simply use the dumps method of the animal dumper object applied on the animal.
Question.
Yeah.
My own habit is to use Nixin for this kind of stuff. Is it better to use that, or is it debatable?
I think it's not debatable in the sense that the facade pattern is better, especially when you want to deal with additional parameters like this. You saw my width div. Here, I really have no problems because once the animal dumper object is created, it is used as any other animal dumper object. So you can use it in a function like save to files, for example, without knowing at all which kind of animal dumper will be used. Yeah. So that being said, my opinion is that maybe the single responsibility principle is the one I break most often among the five, because it tends to really multiply a lot the number of classes that you will have in your project. And when you do simple things, and you, for example, you know that you will always use JSON dumps and never anything else, maybe it's not worth bothering with that. But maybe I would be excommunicated by the church if I say that too loud. Okay, so that's essentially what I was saying in that in that slide. So I think, yeah, for small things, in fact, I will not be shocked if this principle is broken somewhere.
Can you go to the previous example where the final?
Okay, so maybe the most interesting one is this one, because you create an animal dumper HTML object, and this at the initialization of the object, it's the time where you pass the parameters, the options of the object, and then once the object animal dumper is created, it is used exactly in the same way as any animal dumper object, because you just have a method dumps taking an animal in, and you don't want to. In fact, when you program a third-party function like save to files, you don't want to know anything about the subclasses of animal and how they work and so on. And you don't want to know anything about the subclasses of animal dumper, because you can rely on this abstraction. And this relying on abstraction will be another principle, by the way. Just I want to say 2 words about another programming principle. Okay, so in this example, for example, using the facade pattern is a very clean programming habit and so on and so on. But here again, if you really know that you will never use it and so on, maybe having a complicated code base with several classes and so on, just to prepare yourself for something that will never happen, maybe is not worth it. And that's so the other programming principle is you ain't gonna need it. So just do directly what you want and don't prepare for hypothetical stuff. Okay, second principle, so the O in solid, it is the OpenClose Principle. And when I see the name of the principle, I don't understand at all what it means. So in fact, it's really simple. So the original saying is, software entities should be open for extension, but closed for modification. But in fact, it's very simple what it says. When you should need to modify the code only when you want to modify what it does. You have to change your mind and you want that it does something else. And you should have to extend your code when you want to extend what it does. So when you want to add a new feature, you shouldn't have to go into the engine and change the gears and break everything just to add something new. And so you should design your architecture so that you can do that. So let's go with another example. Now I have animals, and this time with an attribute that is called species. And then I write an external function that takes a list of animals in argument. And for each animal in animals, it will test if it's a lion, and it will roar in that case. And it will also test if it's an elephant. And in that case, it will trumpet. So let's go. Animal sounds applied to a lion and an elephant. It roars and it trumpets. Okay, what's the problem?
Well, if you want to change the sound the lion makes,
Or add a new animal.
In fact, in some sense, if you want to change the sounds of the lion, it's not the biggest problem because you want to modify what you decided earlier.
but I feel like the point was you're not supposed to modify. You know?
No. What I said exactly is that you should modify your code if you want to modify its behavior. You should extend your code if you want to extend its behavior, essentially.
For me, I'd like to have a dict somewhere that stores all the correspondence between animals and words, and don't have this if because it tries for.
So yes, generally speaking, in object-oriented programming, if you see a lot of if-elifs, you're doing something wrong, basically.
Two is okay. But...
Yeah. So here the problem, for example, is that if you want to add the feature of a snake in your project, okay, so at the beginning you said, okay, we are just going to manage lions and elephants, will be okay, and you want to add the snake feature. So you will need to modify the code of animal sounds. So formally, it breaks the principle because you are going to modify the code of an existing function just to extend your project. So that's for the formal breaking of the principle.
You're not changing the code, you're adding lines.
Nah. Nah. And the second, and in fact, the very practical problem, say now imagine that you have several functions in your code base that do similar things, that will do if it's a lion, if it's an elephant, if it's and so on and so on. And if it's everywhere in different files in your project and so on. So when you come and say, okay, I will add a snake, you will need to go to a kind of treasure hunt to find all the places in your code when there is such a if then to just implement the snake feature. And you will probably forget some of these places and you will have bugs. Blah, 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 blah. That's what I said. So in fact, here, of course, the good solution is to do classes. That's precisely what classes are for. Because this way, when you want to implement a new animal, you will simply make a new class. And since there is a list of methods in the animal class, you will simply need to implement all the methods that you need that there is in the parent class. So here I have an abstract class animal with a method makeSound, and each animal implements the sound that it makes. And now it's not the responsibility of my third-party function animal sounds to decide what lion makes or what snake makes. After all, it's the responsibility of the snakes to know if they hiss or something else. And the animal sounds third-party function will simply ask the animal the sound that he makes. And let's go. Of course, it works. So some comments on this solution. If I want to extend the project with another animal, like a dog that barks, then I will simply extend the code by adding another subclass dog and implementing all the methods that an animal is supposed to implement. And for example, if I want to modify the snake so that it rattles instead of hissing, then I will modify the code of snake, but it's just because I want to modify what it does. Okay, now
can I still challenge you?
Yeah, go.
So I understand that in the end, instead of having lots of if, you write a bunch of classes. So of course I understand why the solution of using a dict is not necessarily brilliant, but can you automate the creation of classes from a dict? I don't know, it's a real question.
I don't know.
Without using eval, of course.
I don't know, that will be your homework for next time.
Because yes, some people may want to have a clean list of association between spaces and sound, and just automate this without having to write actual codes, which is always the same.
Yes, but once again, the question is when you will want to imagine that, for example, you have a dict for the sounds of the animal, a dict for the way they breed offspring, a dict for the way they walk, they swim, and so on. And really, there is a huge risk that the way when you add a new animal, you
or you have one
yeah. Or at least, yeah, maybe you have a class that is a database of animal with a method to add a new animal that prevents you from forgetting something and so on. In that case, I think, yeah. So managing it like a database with a kind of safety constraint and so on, maybe would be safer, I think. Okay, so third principle, the Liskov substitution principle. Functions that use pointers or references to base classes, must be able to use objects of derived classes without knowing it. So if you understand that sentence, you're very, very strong. In simpler words, in any place where you can use an object of a parent class, the code must still work if you use an object of a subclass. So if you design your code in a way that violates that, you're probably doing something wrong. So this principle existed well before Robert C. Martin's paper, because it was introduced by Barbara Liskov in a conference keynote in 1987. So in fact, the Liskov substitution principle has many consequences, and I will just show you 3 of them. The first consequence is that the method of an object of a subclass can be more tolerant on its input than the one of an object of the parent class, but it cannot be less tolerant. Okay, and conversely, the method of a subclass can be more restrictive on its output than the parent class, but it can now allow for new kinds of outputs. Okay, so you can think of it. So I discussed that with Maxime a few days ago, and you can make the parallel, for example, when you're implementing the standard. Okay, you want to implement a standard of communication, for example. So maybe you are making a router or a network device, whatever. Okay, so the official standards tell you that you must accept such and such input, and you must provide such and such output. Okay. If you are a bit more tolerant on the input and say, okay, if the integer is given in the form of a string, for example, I will be nice and I will try to understand that it's an integer in the form of a string, even if it's not asked by the standard. So you can be more tolerant on the input, preventing that you do what you are supposed to do with the inputs that are mandatory in the standard. And conversely, in the output, maybe the standard tell you, okay, if you want, you can output an integer, or you can input a string that represents an integer or something like that. In fact, if you choose to always return an integer and be less tolerant on your output, nobody will have problem managing what you do. Okay, so that's exactly the same idea. And a third consequence of Liskov substitution principle also is that a provable property, and I will not say what it is exactly, on the parent class should still be true on the subclass. So I will give an example of that a bit later. So consequence on the inputs. So let's play hide and seek. I have a class player. My class player has a method count with a parameter n to count up to n, and a method search to search for other hidden players. And then I say, okay, I want to implement a new kind of player, but in fact, these players will be babies, so they don't know how to count until more than 5. So I say, okay, if n is greater than 5, then I will raise a value error. And in the other case, I will count up to n. And I don't implement the method search because anyway, I can benefit by inheritance. I will benefit from the method search of the parent class. Okay, can you see the problem? No, okay, I go. Okay, so imagine that another developer of good faith say, okay, I know the class player, so I am going to implement a game of hide and seek. And for that, I will take a player in arguments. I will ask my player to count up to 100, and then my player is going to begin the search. Let's go. So now I have applied this with an instance of player. It works. It counts up to 100, and then it begins searching. And then since I am asked a player object here, I am fully in right to hope that the program will work with the player baby because it's a subclass of player. So let's go. And of course, I have a problem because the values that are greater than 5 are not accepted by player baby. So here is a possible solution. I implement a class that is called player knowing at least 5 numbers. That by contract is supposed to be able to count up to 1, 2, 3, 4, 5, and that's it. And a method search, and then I will implement a subclass that is player adult. That is a subclass of player knowing at least 5 numbers, but nobody prevents my player adult to be able to count to more than 5. And then for my player baby, so I had fun making a little program with baby words. Okay, so now if I want to play hide and seek, of course, I cannot request here a player knowing at least 5 number because that's not what I need for my hide and seek. I need somebody who is able to count up to more. So for example, a player adult, and then go. And go, so it works. And nothing prevents me from implementing a hide and seek junior when I asked player only to count up to 5. And in that case, what I need is just an instance of player knowing at least 5 numbers. And of course, even if I designed this having babies in mind, it will also work for adults because adults are also able to count up to 5.
I have a remark and a question. So I suspect you had help for the words of the babies, and I don't
no, because my babies don't speak English.
And,
for some of them, it's indistinguishable for the moment between English and French.
and second, I have a question. So clearly, every method of the child of a class must have the same arguments, right?
Almost, yeah.
Yeah, it can have additional optional arguments.
For example,
but you cannot have less arguments, for example, or something like that.
Exactly.
But the init method, is it the same?
No.
Or, are we
no. Yeah, that's a very good remark. And in fact, I don't know if you noticed, but when I read this sentence, I was a bit more precise. I said the method of an object of a subclass can be more tolerant than the, and that's important, especially for the init, because you can have totally different inits for the subclasses. You don't care. What you care about is that once the object is created, it has the expected behavior of an object of the parent class. Okay, now consequence on the outputs. Let's now consider animals again, mammals in that case, with a give birth method, and this give birth will return a new object of the same class, a new animal of the same class, and it will also return the time of birth. And to simulate the time of birth, I simply use the current time. And also, my mammals have another method which is called make sound to make a sound. So now I implement a lion. I don't need to override the method giveBirth because the method of the parent class works very well. And I will just override the method makeSound so that my lion roars. And then one day I want to implement a platypus. And as you may know, platypus lay eggs, unlike most of the mammals. So I have a seemingly good idea of saying, okay, now what is the time of birth for a platypus? In some sense, there are two times. There is the times where the egg is made and the time when the egg hatches. So instead of a two-element tuple, I will return a three-element tuple with the time of hatching, which is in some sense the real birth of the animal, and also the time where the egg was laid. So let's go. I think you can spot the problem this time. Yeah, it's dirty. Okay, so once again, imagine that you are a good faith developer. You know the class mammal, you know what it's supposed to be able to do, and you want to take a list of mammals in parameter. And for each of these mammals, you will tell them to generate an offspring, and you will ask this offspring to make a sound. So for that, you will call the method giveBirth. You will unpack the tuple by saying, okay, I want the offspring, and the second part of the tuple, I just don't care. And then I will ask the offspring to make a sound. So of course, if you do that with a generic mammal and a lion, it will work. So the newborn little generic mammal will make a generic sound, and the little lion will roar. But of course, if you do that with a platypus, you will have a problem, because at the moment when you do the unpacking, you have three elements and you want to unpack them into two elements. So it doesn't work. So maybe we don't care so much about a possible solution here. In fact, there are probably better solutions than the one I propose here, but I want to propose a solution that is as simple as possible. And here, the solution that I proposed was simply to return the tuple with the offspring itself and a dictionary of additional information with, for example, the date of birth, the name of the mother, and anything that you might want. Okay, so just to gather our observations about the inputs and the outputs and the Liskov substitution principle, if you have, so here to paraphrase Eli, it's not really parent class method, but an object of the parent class dot method that goes from set E to a set F, and for the subclass object, you have E prime and F prime. In fact, you want two inverse inclusion relations. You want the child input set to be at least as large as the input set of the parent class, and the output set you want it to be at most as large as the one of the parent class. So it's not exactly like that, but that's the let's say the ideal idea that you should have in mind. And another way to say it is that an output value of the subclass should not surprise and cause bugs for someone who expects an output value from the parent. Sorry. Yes. Okay. Now, third example on the Liskov substitution principle and its consequence on so-called provable properties. So we will have a look in a moment to rectangles and squares. And in fact, it's very, very bizarre, I think, because this example is very often given as the first example for the Liskov substitution principle. And in my opinion, it's a very complicated and subtle example. And in fact, the violations that I showed you earlier are very more frequent, at least for beginners. So let's go. We want to implement a rectangle. That's easy. I will say, okay, I have an attribute width, an attribute height. I will record them in the self.width and self.height. And I have a method that is called area that returns the product of the two. Okay, let's go. Now I want to implement squares. Easy, right? Because squares are a subset of rectangles. Sorry, there's another step before. In fact, I will not use this simple implementation of a rectangle. I will use a slightly less complicated with setters and getters, and you will see why in a few minutes. It's okay for you, setters and getters in Python? Yes? No? Okay, so in fact, instead of doing that, saying, okay, I have an attribute that is called width and that contains what I entered as width, what I can do is to have a method width with the @property decorator that will be responsible to give me the value of the width. And I will have a method that is also called width, but with the width setter decorator that will be responsible to modify the value of the width. And that can be useful if I want to do more complicated stuff. For example, if I want to check the value that is given before modifying the attributes, or if I want to modify other attributes in the same time, and so on. And that's why I do that now, because I want to do that for the square, in fact. So here, we simply record the value of the width in a variable that is called underscore width. So starting with underscore, it means that it's somehow hidden to the user. And when the user wants to get the value of the width, I will simply return the underscore width. And when I want to modify the value of the width, I will simply modify the value of underscore width. It's really boilerplate code, a lot of lines for not much. Okay, so now when I implement squares, I say, okay, squares are a subset of the rectangles. So it's really my idea of what a subclass is. It's if I have a subset, probably I want to do a subclass. So I will do a subclass of a square. So the difference will be that when I initialize a square, I will just give a length, because it's no use giving width and the height separately. And I will use the init of the parent class, the init of the rectangle, with the same parameter for the width and for the height. But now, if I want to modify the width, for example, since my object is a square, I want to modify the height in the same time. So it modifies my setter. I will implement, I will override my setter and say, okay, if you tell me now a square dot width equal 4, for example, I will modify the width, but I will also modify the height.
Quick question: you don't need to implement the getters.
In fact, I had an error when I didn't. Okay. So I guess that to be able to use the setter decorator, you need to use the getter, the property decorator in the same class.
You end up writing up the full code.
Yeah, I know. But at the beginning, I hadn't written the getter, and I had to do it. Yeah. So now, do you see the problem?
Where is more restricted? So you want the input to be, you want the subclass input to be less restrictive, right?
It's in fact, so as we said earlier with Ellie, in some sense, you're more restrictive on when you initialize the object. But for example, when you do a square dot width is equal to 4, that's something that you can also do with a rectangle. So you don't forbid things that are doable with a rectangle. So that's not exactly the problem.
If you write code that takes as input a rectangle, half its width and outputs the area, it's gonna behave differently for true rectangle.
Exactly. That's exactly the example of a provable properties on rectangle. If you have the width, you should have the area, and it's not true for our square objects. So that's not exactly the example that I'm going to take, but it's really in the same spirit as what you said. So imagine now that I'm a third-party developer and I know the class rectangle. So I will, I say, okay, I will do a function that will take a rectangle and that will modify its width so that the area will be normalized. Okay, so I will say, okay, I compute 1 over the height, and this is the new value of the width, so that I'm sure that now my rectangle is normalized. Okay, so let's go. If I do that with a rectangle of width 2 and height 10, I modify the width to normalize the area of my rectangle. I print my area. It's 1. Everything is fine. But now, okay, I'm a simple user. I say, okay, my function modify width to normalize area requires to have a rectangle as an input. So it's perfectly legal to put a square as an input there. And I will try to use it with a square of length 2. And of course, it doesn't work because it computed the inverse of the height, which is 1/2. It modified the width so that it is 1/2, but incidentally, it modified the height to be 1/2 too, and the final area is 0.25. A good explanation of the problem, and I saw it on a forum, and it's not explained in most web pages, is that in fact here the class rectangle does not model rectangles in the mathematical sense. It models reshapeable rectangles where you can modify the width and the height independently. And in that sense, square is not a subset of rectangles because it's not reshapeable rectangles where you can modify the width and height independently. So there are different solutions to that problem. It depends on what you really want to do. Do you want really to model rectangles? Do you want to model reshapeable rectangles and so on? If you just want to model rectangles, maybe the simplest solution is to make them immutable. So let's go. So here you can see that I have made a getter for the width, so I can get the width, but I have I've put no setter, and when you put no setter, in fact, it will raise an error if you try to modify the width. And similarly for the height, so you're not, in some sense, you're not allowed to modify the height, even if there are always some tricks in Python to do it. I just added a rep method just for display, and now my square is a subclass of rectangle, and in fact I initialize my square with as a rectangle with the right width and length. So let's go. Okay. So now if I want to rewrite my function to normalize the area of a rectangle, I cannot modify the rectangle in place like in my former version. So I will do a method that returns a new rectangle. And this new rectangle will have the width that is 1 over the height and the height as before. So if I apply that to a regular rectangle, it works. It returns a new rectangle of width 1/10 and of height 10. And since here I have rectangle in an output, I can use a square. And if I do it on a square, in fact, it will work and do something reasonable, which is outputting a rectangle of width 0.5 and height
2. Start getting towards the philosophy of functional programming. The fact that you say you make it immutable and then just I mean, that's kind of the thing they talk about, right?
Yes.
You don't have all these side effects, and you're trying to get rid of these bad things.
Yeah. In some sense, Maxime here, for example, could talk a lot about it. In many situations, when you don't need to make things mutable, just keep them immutable or assume that they are, and you will avoid a lot of problems. Now the fourth principle, which is the I in solid, try to go a bit faster, the interface segregation principle, saying that many client-specific interfaces are better than one general-purpose interface. Not another way to say that, but in consequence of that is that a class should not be forced to implement an interface that it does not use. So since I'm a Nokia guy, I'm going to go into communication device. So I have a parent class communication device with several methods: make calls, send SMS, browse the internet. And then I have this subclass, which is a smartphone with that implements the making calls, sending SMS, and browsing the internet. Can you spot the problem? Okay.
So many communication devices can't browse the internet.
Exactly. So now imagine that I want to implement a landline phone. So I will inherit from communication device. I will only implement the make call method, but whether I want it or not, I will inherit from the other methods of the parent class. So now if a third-party developer or myself a few weeks later, I design a function that takes a list of communication devices in argument and that asks them to browse the internet. If I do that on a list with just a smartphone, of course, it will do what it's supposed to do, but I can legally put a landline phone in my list, and then it will work. And here it's a big problem that it works, because that's what I would call a silent bug, in the sense that you don't have an error, but it should raise an error, in fact. So this is the first idea of solution. You will say, okay, I will override the method that I don't want to use, and I will make them raise an error. Okay, so let's go. So now it's better. At least the bug is not silenced, but now it violates the Liskov substitution principle. And that's another consequence of the Liskov substitution that I didn't mention earlier. An object of a subclass should not raise an error that is not part of the errors that can be output by the parent class. And another way of saying that is that if I do that, afterwards I will see that I have done something bad, but syntactically nothing prevented me from writing that. Nothing prevented me from putting a landline phone here, and I needed to rely on human knowledge to know that asking a landline phone to browse the internet is stupid. I don't have any syntactic guarantee of what am I doing is reasonable. Sorry. So here, in fact, the good solution is to use the interface segregation principle and to say, okay, there's no communication device. In fact, there are calling devices, there are messaging devices, there are internet browsing devices, and some devices happen to be the three of them. Some device happen to be only one of them. And here, so the smartphone does everything, but the landline phone doesn't. Okay, so now if we rewrite each device browses the internet, of course, I will not ask a list of communication devices. I will just ask a list of devices that are able to browse the internet. Okay, and now the last one, the dependency inversion principle. So we should.
For that solution, do you not get into trouble where the parent classes maybe have common functions that may be implemented differently?
Sorry?
So suppose both calling device and internet browsing device had a make call function.
Yeah.
And suppose you didn't implement the make call in the smartphone. Don't you get into problems you don't know which make call is going to be used?
Yeah, that's possible. Maybe you need to make sure that you will not have conflicts, because I don't think that Python will tell you that you have name conflicts in that case. Yeah. So in fact, here you could do another design. Instead of using inheritance, you could use a kind of composition, I guess, to say, okay, in fact, you have your smartphone has a messaging service, has an internet browsing service, has a making call service, and so your smartphone has three attributes, each one for one of the services, and then you don't have name conflicts if you are afraid to have this kind of problems. Okay, the last one, dependency inversion principle. You should depend on abstractions and not concretions. And there are two main avatars of that. Abstractions should not depend on details, but the reverse. And high-level modules shouldn't depend on low-level modules. And both should depend on abstraction. I will show some examples of that. So the first one is that abstractions should not depend on details. So here I have a class that is supposed to record which persons belong to different teams. So there is these attributes with a dictionary that to each team associates a set of persons. And when I want to put a person in a team, I will just add this person to the relevant set. Okay, now assume that I have another class that is responsible of some analysis on the team memberships. And for example, here I just want to know which persons are in a given team. So I will say, okay, the persons are so I take the dictionary of the team membership subject. I take the value corresponding to team. It's a set of persons. Okay, so I'm happy. And for each person of this set, I will print that this person is in the team. So let's go. Here I create a team membership subject. I record Alice in team 1, Bob in team 2, Kate in team 2. And then with my analyze, I will analyze team memberships and asking what persons are in team 2. So it works. But here the problem, of course, is that if I change the implementation of team membership, maybe I will have a problem. Sorry. So imagine now that instead of a dictionary that to each team associates a set of persons, I have a dictionary that to each person associates the number of their team. Essentially, the feature, what the feature of this class is the same. It's just implemented differently. And now when I put a person in the team, it's a bit different because I will just update the dictionary entry that is related to this person. So does our analyze function still work? Of course not, because it relies on the team persons, and this dictionary does not exist anymore. So who's the fault? In fact, in more strict languages like Java, for example, everybody would say that it's the fault of analysis, of the class analysis, because it accessed the attribute the team persons without using a getter method. So it did not respect encapsulation, the fact that you should not access the attributes of another object directly, but you should use methods to interact with another object. In fact, in Python, it is a bit less clear because this attribute, the team persons, is public. And so it can be considered part of the API, and analysis can say, okay, I have the right to use it because it's public, it's part of the API. So it's the fault of team memberships because team memberships change its API without telling the whole world that they may need to change their code. There are messages in the chat. Okay. So a first good solution would be to say, okay, I will change the implementation of team memberships, but I will maintain the API. So even if internally I'm using the person teams, I will implement a property the team persons just to be backward compatible with the way that I worked before. So if somebody else relies on using this dictionary that to each team associates a list of persons, this will still work because I would just build this dictionary on the fly. And then I don't need to change the code of analysis, it will still work. Another solution that is good also is imagine that from the very beginning, a team membership decided that the team persons was not part of the API. Then in that case, you just tell it by putting an underscore at the beginning of this variable. And by doing that, you just say the whole world, okay, don't rely on that attribute. If you do this, maybe you will have troubles one day. Okay, And now the
That's
last
just a convention, the underscore, right? Python will still let you access it externally.
Yeah.
Yeah.
Yeah. Yeah. Yeah. Python is supposed to be used by grown-ups knowing what they do and yeah, in good faith. So it does not prevent you from using this attribute, but you should know that you're doing something risky. Okay, so my last example, we have now a car wash service. So illustrating that high-level modules should not depend on low-level modules. So here I have a car wash service that sends SMS when the wash of the car is completed. So I have this low-level module SMS notifier that sends an SMS with a string of characters. And when I say it's a low-level module, I just mean that it could exist independently of the car wash. It doesn't need the car wash to work. On the contrary, the car wash needs the SMS notifier, and it's a high-level module in that sense. And when so my car wash service has a method wash completed, and which will take a SMS notifier object and send an SMS. So here, of course, we have a problem. If we one day, if we want to add the option, for example, of using an email notifier instead of the SMS notifier, I will not be able to do it because the fact of using an SMS notifier is hard-coded into the heart of the function wash complete. That's not good, and it would break, by the way, the OpenClose principle. So a good way to do that is to say, okay, my SMS notifier, which is a concretion of a low-level module, I will make it different from an abstraction, so general notifier. And I just need that my general notifier is able to send a message. I don't care if it's an SMS or an email or a Python. And my car wash service now will take a notifier in argument when it is created, and it will just send a message with this notifier. So now when I instantiate a car wash service, I will put a notifier in argument to say which kind of notifier I want. And even if for the moment I have only SMS notifiers, my code will be easily extendable in the future. Blah, blah, blah. You can be more quick and dirty sometimes, especially in research-oriented code. And to conclude, so 5 principles: single responsibility, OpenClose principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Now, how can you spot when you do not apply solid principles? As I said earlier, you're writing a lot of if statements to handle different situations in object code. Generally, that's a hint that you should probably do things differently. You're writing a lot of code that doesn't actually do anything, just to satisfy interface design. You keep opening the same class to change the code. And also, you are writing code in classes that don't really have anything to do with that class. For example, putting SQL queries in a class outside the database connection class just because you're managing the wires inside the class. Okay, thank you very much, and sorry for being a bit late. Do you have questions?
Is it fair to say that a lot of this means having a lot of classes is generally good? It seems that a lot of your solutions involve writing more classes.
Yeah,
so is that a general principle?
Yeah, more classes, more functions, and I think a very good criterion also is your code easy to test? Yeah, if you have small code entities, it's very easy to write unit tests. If you have a code entity that implements a whole algorithm of 200 lines, it's almost sure that you will have a bug in the middle of it and you won't even know it.